Hey guys, how's it going? Mr. D here with another video on Chapter 5. Today we're going to be talking about systems of linear inequalities. So on the previous video that you guys might have watched for 5.1, I hope you guys still remember a little bit about systems of linear equations. Alright, all it really was two linear equations that were both graphed on the same coordinate plane, and we were able to identify its solutions by looking at its intersection points. So now we're actually going to move our focus a little bit into actual inequalities instead of equations. And so we're going to be talking a little bit about systems of linear inequalities. Okay. All right. So just before we get started, let's go ahead and recap a little bit of what we know on inequalities. So this is material from Chapter 4. You guys should have learned this on Chapter 4. So let's go ahead and recap a little bit here. So we know that when graphing inequalities on the coordinate plane, solid lines are used for the signs less than or equal to and greater than or equal to, okay? The way I always say it is, does it have a little solid line under the symbol? Yes, it does. So then it has to be a solid line on the coordinate plane, okay? Now for this dash lines, we are actually going to use less than and greater than symbols, okay? So we've used up all four of our symbols. So again, less than or equal to and greater than or equal to are solid lines. Dash lines are just less than and greater than symbols, okay? Now, for less than symbols, all right, which I showed you both right here. So for less than symbols, it means we have to shade below. And for greater than symbols, which are right here, we have to shade above. Okay? And I think if you start to think about it a little bit, it makes sense that when you think of less, you think below or just overall less, which means you have to go lower, right? So that means that less than has to be below, and on the opposite corner, greater than has to be above. Okay? So let's go ahead and actually start to look at some inequalities just like we did in Chapter 4, and then we're going to see how we can combine those two in order to actually create a system, okay? So let's go ahead and figure out what our slope is for number 1. So let's see. It says graph the linear inequalities on the coordinate plane. So again, like I said, let's find our slope first. Our slope we can identify here as 2, or you can write it as 2 over 1. Really doesn't matter. Okay, and our y-intercept is 0, comma, negative 4. Now, if you are confused as to how I'm getting those numbers, just look. This looks like it's in y equals mx plus b form, right? This right here. Except for it's now an inequality. But we should still be able to derive the information that we need. We still have a slope. So let me go ahead and grab my highlighter here. We still have a slope. And we still have a y-intercept, a b. Okay? So that's where I was getting those two numbers from. All right, so let's go ahead and continue. Now, it's asking, do we want a solid or a dashed line? Well, let's see. What's our symbol here? Our symbol here is just a greater than symbol. It's not a greater than or equal to, so we don't need a solid line. We just need a dashed line, okay? So again, what was I looking at? I was looking at this. Let me go ahead and erase some of this highlighting that I did already. All I was looking at was this right here. This symbol, is, if we look up here, where do we see that symbol? Well, it's right there. So it means we have to do a dashed line. Okay? So let's go back to our problem. So we know we have to have a dashed line. Now it asks, do we have to shade above or below? Well, again, it's a greater than symbol. So let's look here. Where's the greater than symbol? It's right there. It's greater than, so we have to shade above. Okay? So let's go ahead and go down here. We want to shade above. So let's see if we can go ahead and graph this. So I always say start with your y-intercept, guys. Start graphing your y-intercept first. So 0, comma, negative 4 is right down there. My slope is 2 over 1, which means I go up to right 1. So up to right 1, up to right 1, and you can keep going. Okay, or you could do the exact opposite, which is down to left 1. All right, now before I start just drawing a random line here, let's look. it says we want a dashed line. So let's go ahead and make it a dashed line. So do your best to do a dashed line. You could use a straight edge if that helps you. Okay, so we have a dashed line. Now we have to talk about shading. Well, shade above or below. Well, it looks like we're being asked to shade above, but which is above? Is it all of this? Or is it all of this? Well, we have to figure that out. So let's see. This is what I like to do, and if it helps you guys out, I recommend that you guys try it out. From the corner, or from this line, I'm going to go ahead and draw some arrows. So here I'm going to draw some perpendicular arrows, right? They're making like little 90-degree angles here. Okay, and then I'm going to draw a few over here that are going the opposite way. They're also perpendicular to that red line. Which set of arrows look like they're actually going up? Well, if you guys look closely, these right here look like they're kind of going up. They're going up and to the left. These, on the other hand, are going down and to the right. So we don't want to shade below, okay? We actually want to shade above. So what am I going to shade? I'm going to shade everything up here, okay? So this is what we have to shade. So that is our solution set, okay? All right. So why don't we go ahead and do one more together to make sure this makes sense. All right, so let's go ahead and take a look at number 2. So we have y is greater than or equal to negative 1/2 x plus 3. Well, again, even though it's an inequality, it still looks like it's in slope-intercept form that we're used to, right? It still looks like a y equals mx plus b. So we can identify what? We can identify our slope and our y-intercept. So let's go ahead and write those two things down. We have our slope, it's negative 1/2. And we have our y-intercept, which is 0, 3. Now, do we have to use a solid or a dashed line? Well, let's see. What's our symbol here? Our symbol here is a greater than or equal to. So as we see in the chart above, greater than or equal to, because it does have that little equal to sign, then we definitely do have to do a solid line. Okay? And now are we shading above or below? Well, again, it's y is greater than or equal to, okay? So greater means we have to shade above, okay? So we have to shade above. All right? We have all the information we need. Let's go ahead and start drawing our inequality. So start always at the y-intercept. So I'm going to go ahead and grab 0, 3. And again, my slope, if you guys remember, there's the negative 1 on top, so it's going to go down 1, and you always run to the right, so it's right 2. So let's go ahead and keep drawing our graph. So, whoops, sorry about that, guys. Scroll back up here. All right, so down 1 to the right 2, down 1, right 2, down 1, right 2. Or remember, we can always do the exact opposite, which is up 1, left 2, up 1, left 2, and so on. Okay? So again, this time it called for a solid line, so I can just make a straight solid line through all of those points. I did my best there, freehand. And now we have to shade above. Well, again, if you start making little arrows, guys, try to figure out which side you have to shade. Are these looking like they're going above, or are these looking like they're going above? Well, I'm sure you can tell already that it's these right here that look like we're shading above. So that is your solution set. Okay? All right. Now, as you might have remembered from what I said earlier, this is basically what we did in chapter 4. Now we're going to add a little bit to it. Okay? So now we're actually going to graph the two inequalities on the same coordinate plane. Kind of like what we did with linear equations, right? So systems of linear equations, we just graphed them both on the same coordinate plane. Well, we're going to do the same thing with these inequalities. So I'm going to go ahead and graph that first one that I did in red. Let me go ahead and do that. So this one was whoops, this was a y-intercept of 0, -4. My slope was 2 over 1. Okay. All right, so let me go ahead and draw my dashed line through those points. All right, now I'm going to go ahead and graph this other one. So I had a y-intercept of 0, 3, and then my slope was -1/2. So let me do that one in green. Okay. And remember on this one we had a solid line, so you can draw a straight line through that whole thing, through every single one of those points. All right, so we have both of our inequalities now. The most important part here is that we have shaded regions. However, in order to have a system that works, we have to make sure that our solution set is a set of points that both satisfy the original first inequality that I have here in purple and also this inequality here that I have in blue. So let's actually go ahead and figure out which way we had to shade. So this is what I'm going to do. I'm going to go ahead and take a, let's take a black marker. So again, for the red line, we shaded above. Okay, actually, on both of them we shaded above. Okay, so this is what I'm going to do. I'm going to use arrows to represent the fact that I'm shading above. So I'm going to take arrows all the way on my red line, from problem number 1, sorry, and I'm going to just draw these little arrows to show that I did have to shade above. Now what I'm going to do is I'm going to do the same thing, but now with my green graph. Okay. Again, I also had to shade above here, so I'm going to draw a bunch of arrows coming from that green graph, showing that I have to shade above. Now, what last thing I'm going to do here is I'm going to basically separate this entire coordinate plane into 4 regions. Okay? The goal here is this. Where do you have to shade now? Well, let's see. The place where you have to shade now is the place where you see the arrows from both graphs kind of like they're intersecting. They're matching up. Okay? Well, there's nothing in region 4 right away that I can see is going to region 4. None of the arrows are pointing towards region 4. So I'm going to erase that. Okay? For region 3, yeah, those purple lines that I drew coming from the green inequality, they do go there, but the black ones are going to a different region. So region 3 doesn't work. Same thing here for region 1. These little black arrows are going towards region 1, but not the purple arrows, so not this one. But notice now that both these little purple arrows and the black arrows are both crossing in region 2, meaning this is the area that I have to shade. Okay, and actually let me do that in a different color here. Oh no, I don't want to do that color. Let's try that again. So that is my shaded region, or another way to say it, that is my solution set. All of the points that are on that green area that is shaded will be solutions to my system of inequalities. Okay. So now that what's being asked, it's asking, is 0, 6 a solution to this system? All right, well, let's figure out where 0, 6 is. 0, 6 is right up, whoops, right up here. Is that in the green region? Yes, it is. So yes, it is a solution. Okay, all right. So now that we have a little bit of a better idea of how to graph these, let's just give a little definition of what it is to be a system of linear inequalities. So all a system of linear inequalities is a set of 2 or more inequalities that are graphed on the same coordinate plane. Okay. For the most part, we're going to be dealing with just a set of 2 inequalities, but you can have more in whatever kind of system that you come up with. But for now, like I said, we're only going to deal with a set of 2 inequalities. So that's all it is. A set of 2 or more inequalities that are graphed on the same coordinate plane. They each have restrictions. So now we're going to basically match them both and figure out what new solution set comes about those 2 different inequalities. All right, so what I want to do is actually do one more with you guys, and actually I'm gonna do one more with you guys, and then I'm gonna have you guys try a few on your own. Okay, the one that I want to do with you guys is number 2, and I'll let you guys try out number 1 on your own. So let's go ahead and take a look at number 2. So number 2, this first one up here, let me go ahead and highlight it so you know which one I'm talking about. That first one here looks like it's already in slope-intercept form. All right, so what are my slope and what are my intercepts? Well, my slope here would be -4 over 1. Okay, I'm just writing it as a fraction, so it's easier for me to see which way I'm going to have to move. Okay, and my b, or my y-intercept, is 2. So my y-intercept is 0, comma 2. I'm going to go ahead and actually graph that line in red. Okay, so I'm going to go ahead and graph this line here in red. All right, so let's figure out what this inequality looks like. So start at the y-intercept, which is 0, comma 2. Okay, now, before I even do anything else, well, actually, I can go ahead and use the slope. Let's go ahead and use the slope. So we're going to go down 4 to the right 1, down 4 to the right 1, down 4 to the right 1, down, or we could do the exact opposite, which is up 4 to the left 1, up 4 to the left 1. Now, the reason why I want to stop here for a second is because we have to determine, are we going to shade above, or are we going to shade below? Well, it's a less than. Y is less than. Okay, so do we have to use a solid line or a dashed line? Well, it doesn't have an equal to underneath, right? So this means we have to do a dashed line. Okay, if you're not sure how I'm getting the fact that this is a dashed line, go back up to the chart at the very top of the front page and verify that it does have to be a dash. Okay, remember, less than or greater than, take a dash line, less than or equal to, whoops, sorry, or a greater than or equal to, both of those would take a solid line. Okay, I'm not going to scroll back up just because I don't want to move around too much here because my computer is acting up a little bit. So let's go ahead and draw a dashed line. All right, draw your 2 arrows. Now we have to figure out which way do we shade. Well, again, it's a less than symbol, okay? And less than means we have to shade below, okay? So now, again, this is another way to figure out which way is below. If you take your pencil and you drag it to either side of that line, you'll notice that your pencil starts going down and to the left if you shade in this area, okay? So this area would be below. Again, we had a less than symbol, so this means that we have to shade below. Okay. So I'm showing you 2 different methods here of doing this problem, guys. Remember how we did it originally with those little arrows because we're doing a system? I'm actually going to show you by actually shading it in so you guys can see where the 2 arrows would actually cross. Okay, so let's go ahead now and graph the second line. So that would be this one. All right, and just to save up some room, I'm going to go ahead and erase this. So we have a y is less than or equal to -2. This looks very familiar to this type of line, which would be what? If you guys remember, that's the line that either has to cross the y-axis or the x-axis, meaning It has to either be vertical or horizontal. Well, in this case, it starts with a y equals, meaning it has to cross the y-axis. So it's going to be a horizontal line, and it's going to cross right here at -2. Now, the symbol that we have here is a less than or equal to. Because it's an equal to, then it definitely is going to be a solid line. So that is my solid blue line. Now, according to that solid blue line, which way do I have to shade? Well, it's y is less than or equal to -2. So I'm going to take, let's go ahead and take a green highlighter here. So what I'm going to do is I'm going to shade below. So below would mean all of this area. And notice what's happening, guys. Which area turned completely black? Well, that was the area that met and satisfied both inequalities, okay? Like I said, I didn't do this the first time with a highlighter. I did it with arrows, but the exact same thing applies, okay? So this black region, that is my solution set, okay? That is the only thing you would actually need. So now if I wanted to, I could do this. I can erase all of this that I originally highlighted this, and just go ahead and highlight this as my only shaded region. Okay, that satisfied both inequalities. Okay, again, if you had done it with your arrows, this is what it would have looked like. You would have shaded below down here, so a bunch of arrows going like that, and you would have also shaded below under this y is less than or equal to -2 line. So in what region do they actually both match? Well, if you notice, it's definitely not region 1, it's not region 2, not region 3, but rather in region 4, there's both green arrows and purple arrows crisscrossing each other, hence why we had to go ahead and shade area number 4. Okay, so you can use either method, guys. You can start shading both sides already and see where they cross, or just start using the arrows, whichever you want. Okay, I don't want to confuse you guys any more than that. So what I'm going to do is I'm going to let you guys try out number 1 and see what you guys get on that one. So go ahead and pause the video right now and try it out. All right, so let's go ahead and graph these two inequalities here. So this one right here, I'm going to actually do in a little bit of a light blue. Okay, so I have y is greater than or equal to -3x plus 6. So I can tell you right away that my slope here is -3/1, and my y-intercept is 0, 6. Now, am I going to use a solid or dashed line? Well, it has this little equal to underneath, right? Has that little equal to underneath, meaning it's going to be a dashed. Okay, it's going to be a dashed line. And it also is a greater than or equal to. So greater means we have to shade above or below. It actually means we have to shade above. So we're going to shade above. All right, so let's put that all together in our inequality here. Let me erase all these little things here. Okay, so 0, 6 right there. Down 3, right 1. Down 3, right 1. Down 3, right 1, and so on and so forth. Or you could do the exact opposites, which is up 3 and left 1. So we know it's going to be a, oh, I'm sorry, why did I say dashed earlier? Let me repeat that then. For some reason I messed that up. Good thing I caught myself. Because it does have this little line underneath, guys, this is going to be a solid. Okay, going to be a solid line. Okay, because it has the equal to, it has to be solid. All right, so this is going to be a solid line. All right, we have a solid line. Now we know we have to shade above. Okay, so I'm actually going to represent shading above by using arrows, just like we did in that first example problem we did. Okay, So I'm going to leave it at that because I still have to draw my second inequality. So I'm going to go ahead and do this other one in red. So let's go ahead and do that. My slope for that one is 1/2. My y-intercept is 0, -5. Let's see, it's a y is less than, so no equal to, meaning I have to do a dashed line. And again, it's a less than, meaning I have to shade below. Okay, let's put that all together. All right, so first things first, draw your y-intercept. So let's go ahead and do that. 0, -5 is right there. Slope is 1. Whoops. Sorry about that, guys. Slope is 1 up, right 2. 1 up, right 2. We said that this one is going to be a dash line. Let's go ahead and dash it. Okay, my 2 arrows on the side there. Now I also have to shade below, so let me go ahead and use a different color here to make my little arrows showing that I'm going to have to shade below. Okay. Now again, I don't want to keep extending the explanation for this, guys, because I'm sure you guys are getting the concept now. But you guys can probably tell now that the only area where both of those arrows are crossing is right here. So this would be your solution set. Anything in that region would be a solution to both of the inequalities. Okay. Now, what I want to do, because I always, like I said, I always like to extend what you guys know, so you guys get a little bit more of an understanding of what's going on here, is I'm actually going to give me 1 second. Let me check to see if any of these ask for that. Okay. Actually, we're going to do something like what I was about to show you on number 5. So I'll hold off on that for a second, okay? So let's go ahead and try out number 3, and then I'm going to have you try out number 4 on your own. Okay, so let's go ahead and take a look at number 3, see how you guys do on that. So first one is already in slope-intercept form. So again, I'm going to do this one in my light blue. That's not light blue. I'm going to do that in my light blue color here. So my slope here is 5/3. Y-intercept is 0, 2. It's a less than symbol, not a less than or equal to, meaning I only have to do a dash. And because it's less than, I'm going to shade below. So notice how we're getting a little faster at doing this, guys. All right, so let's go ahead and graph it. 0, 2, up 5, right 3. Or the exact opposite, which is down 5, left 3, down 5, left 3. Okay? All right, so let's go ahead and connect those. But remember, this is a dash line. Dash line. Okay? We know we had to shade below on that one, so let's go ahead and take my green marker here. I'm going to do a few arrows showing that I'm going to have to shade below. All right, now let's do the next one. Well, this next one, I'm going to go ahead and do it in red again. And let's see. If we were to pretend for a second that this was an x equals -3 equation, that's something that we know how to do. Remember, that's either a line that crosses the x-axis or the y-axis, meaning it's either vertical or horizontal. We know because it crosses the x-axis, it has to be vertical. So where is -3? It's right there. Okay? Now, we do have an inequality and not an equation, so we have to pay a lot of attention to this now. So this is a less than or equal to, meaning is it going to be solid or dash? Well, it's going to be solid this time. So this one is a solid line. Now, x is less than or equal to -3. Okay. Now, this isn't clear which one is above or below, right? We know it has to be below because it's less than, right? So this has to be shade below. However, this is a vertical line, so there is no above or below. There's only left or right. But you have to start thinking about it, guys. Think about what the inequality says. X is less than or equal to -3. So what numbers are less than or equal to -3? Well, that would be -4, -5, -6. And where are all those numbers? All on the left side. Okay? So that means anything that I have to shade is going to be on the left side. So let me go ahead and take this. So I'm going to have to shade to the left side. And then finally at the end, we have to talk about where I have to actually shade. Well, nothing, let's see. Do you guys see any area where they both cross? I do, right here. This is the only area with where both the green and those blue arrows cross. Nowhere else do they cross, so that's the only area you have to shade. All right. Okay, I think you guys are good to go with number 4. The only thing I do want to help you guys out with number 4 in is this. If you guys take a look at that second inequality, that's not in slope-intercept form, and that's not one of our special x equals or y equals types of lines. So what we're going to have to do is try to get it in slope-intercept form so we can identify these things. So my recommendation to you is get it so that the y is all by itself. So subtract the 3x from both sides. So you should get y is greater than or equal to -3x minus 3. Now you can actually graph this inequality. So go ahead and try these out, guys. So you have these two inequalities, the one in green and the one in red. So go ahead and pause the video right now and try those two out and see how you do. All right, so let's go ahead and figure out how to graph this first green one. So our slope is -1/2. Y-intercept is 0, 2. Let's see, is this a solid or dashed line? Well, we know it's a solid because it has this little equal to sign underneath. It's a solid line, and it's a less than, meaning we have to shade below. So let's go ahead and graph this. So down 1, right 2, down 1, right 2, all the way around. And we know this is a solid line, so you can just use one straight line to connect all those points. All right, so we have our solid line. Which way would we have had to shade? Well, we would have had to shade below. So let's do a few arrows pointing down, just to kind of represent that that's where we would have to shade if it was just one inequality, but we actually have to fulfill the other inequality too. So in red here, we have our new inequality. So we're going to figure out what our slope is. Well, it's right here. It's a -3/1. Y-intercept is 0, -3. Let's see, the symbol is a greater than or equal to, meaning we have to do a solid line. And it's greater than, so we have to shade above. So again, let's graph that. 0, -3. We're going to go down 3 to the right 1, down 3 to the right 1. Or rather, up 3, left 1, up 3, left 1, and keep going. So let's go ahead and do a solid line. Okay, so we did our solid line. So let's go ahead and figure out which way we have to shade. We said we have to shade above, so this way would be above. And this one's a little more clear where the two arrows actually match up and where they cross. And I hope you guys notice that that only area where that happens would be right here. So that is my solution set. So I hope you guys got that answer correct. And now we can actually move on to number 5. Now, the reason why I wanted to wait on explaining this is because number 5 and number 6 do a good job of talking about how we can figure out if a particular order pair is a solution. Now, we can determine that by the graph, or we can determine that algebraically by substituting the values into the inequalities. But let's go ahead and see what I'm talking about here. I don't want to confuse you guys any more than you guys might be already. Okay. So number 5 says determine if the given points are a solution to the system of inequalities. So let's figure it out. -2, comma, -3. So I'm looking right here at A. Okay, let's figure out if that is a solution to this graph that I have for number 5. Okay, well, where would that point be? Well, let's see. -2, -3 would be right there. So would that be a solution? Is it in the shaded region? Yes, it is. So yep, that one checks out. Okay, next one. I'm going to do that one in green here. So 1, comma 1, that would be right there. Is that in the shaded region? Yes, it is. So that one also checks out. All right. Now 2, comma 3 is right here. Now, you might be tempted to say yes because it's an intersection point. Kind of like when we were talking about systems of linear equations. We look for the place where both lines intersect. However, you would be correct if both of those lines were solid, okay? Because we have a dashed line, we're saying that everything in the shaded region works, but when it gets to that dashed line, it never actually touches that line, okay? It would touch a solid line, but it would never actually touch a dashed line, meaning that point 2, comma 3 only works for this line up here, but it does not work for the dashed line, okay? And in order for it to be a solution, it has to work for both. So no, this one is not a solution to this system of inequalities, okay? So, and then obviously all of the above would not apply because C failed, okay? So only A and B were actual solutions to this inequality. Now, this is what I was talking about earlier, guys. So let's say you are given a point, okay? And you want to figure out if it's a solution. Well, it's going to take forever to actually go ahead and graph that entire inequality or that entire system of inequalities on number 6, right? So what we can do in fact here is actually substitute those values into the inequalities. Remember, this is an ordered pair. That's your x and that's your y. So x is 3, y is 0. So what you can do is substitute these values into both this inequality and this inequality. Now, I'm going to write here on the side, only a solution if you get a true statement in both inequalities, okay? It's only going to be a solution if you get a true statement for both inequalities, okay? So why don't we actually go ahead and figure that out. So let's go ahead and substitute those values in for this first one. So I'm going to get 3 minus 2 times 0 is greater than -2, all right? Well, this is really just 3 minus 0 is greater than -2, or in other words, 3 is greater than -2. Is that a true statement, guys? Is 3 greater than -2? Yes, it is. So it passed one of these inequalities. So what we can do now is try out that next one, and if it also passes that one, then we are good to go. It is a solution. So let's see. We have 5 parentheses 3 minus 2 parentheses 0 is greater than 6. This is 15 minus 0 is greater than 6, or just 15 is greater than 6. Is that a true statement? Is 15 greater than 6? Yes, it is. And hence, this is a solution. Yes, it is a solution. Again, to further extend what you guys understand about this, If you were to have actually graphed, so like I said, graph this one in purple, graph this one in orange, and do that whole thing where you graph it, shade certain regions, and figure out the area, the solution set, then you would have noticed that this right here, 3, 0, would have been a point in the shaded region. Kind of like how this one right here, guys, was a point on the shaded region. Okay? And or kind of like how this one was a point on the shaded region. Okay? 3, 0 would have been in the shaded region. Or again, if you don't want to go through all the trouble of graphing it, remember you can always substitute these values in your actual inequality and figure out if you get true statements for both. Okay? If it is true for both, then yes, you have a solution. Okay? All right, I think that is it for today, guys. What I want to do for the next chapter, or rather, not the next chapter, for the next section, is teach you guys how you can actually solve these systems of equations and inequalities by using a different method, and this method is called substitution. Okay. Up until now, we've been solving equations, so systems of equations and systems of inequalities, with just graphing, which is one method of solving. But there is also substituting and elimination. So we're going to do substitution on 5.3. So go ahead and stop the video at this time, and I will see you guys on the next video. All right, guys, take care. Bye.